Hello, everyone. Today, I will introduce to you an article from IEEE named Experience Requirements in Video Game Definition and Testability. In this article, applications are divided into two categories: productivity applications and entertainment applications. Productivity applications are designed to accomplish one or more tasks. Its target is letting users achieve competency as soon as possible. However, entertainment software needs to ensure the fun aspect of a design. It is usually deliberately designed to foster a long-term learning curve for users to promote replayability. For entertainment software, user requirements are divided into emotional requirements and experience requirements. Emotional requirements capture the intent and the means by which a designer expects to induce an emotional state in the player. Experience requirements, description of user, player, and customer experience that must be met or satisfaction goals. We all agree that a properly formed requirement is testable, a necessity for ensuring that design goals are met. This article summarizes how to create testable experience requirements for video games or other entertainment applications with strong subjectivity, and how to test these experience requirements. The article creates and tests the experience requirements for a specific game, analyze the result and challenges of the process, and finally provides some guidance for practitioners. The authors express gameplay design elements as cognitive requirements, mechanical requirements, and visual sensory requirements. There is a simple endless runner game and an example to analyze. In this game, the player controls a character who is constantly running, and the player must take deliberate action to avoid stress or to cross paths with rewards. The intensity of the experience grows over time, usually requiring more complex puzzle solving or ever quicker reactions. Let's take a look. The game example experience timeline. The dotted blue line represents the intensity of the cognitive challenges over time. Challenges occur periodically, but their intensity increases as the player survives the game. The dashed gray line represents the more general dimension of mechanical difficulty. In the example, it might represent the player's apparent speed in the world. The apparent speed starts low, but increases for the first 15 seconds, and then gradually increase in speed. The orange line represents the combination of these dimensions. Players feel that the speed is increasing rapidly, but the challenge is not difficult at the beginning. Players should learn how to control their characters and get used to the speed at which they move during this time. This combination of interaction between dimensions provides the player with the opportunity to learn how to perform in the environment and by extension to achieve a growing degree of success as they learn how to survive in the game environment for longer periods of time. Based on the simple game example, the Lumberjack run game was designed. The mechanical challenge is a strictly linear process wherein the forward speed up on the sequence of logs is constantly increasing. The associated cognitive challenges are presented more frequently and are drawn for the available maze patterns via a random sampling of overlapping distribution of low, medium, and high difficulty challenges. Experience requirements must be translated into functional requirements before they can test it. Here is a typical example. Please note that in game design, the ambiguous term must increase with time and must directly correlate are accepted. The specific market segment are variable. People are very reluctant to be precise at this time because it is perceived as just too difficult to predict what will be perceived as fine. The greatest challenge was with confounding factors. Identifying the possible confounding factors is challenging, and attempting to control for those confounding factors were even more challenging. The authors need to make clear the possible confounding factor, including the player's prior knowledge, dexterity, and hand-eye coordination. The metrics to measure the difficulty of the game are also needed. In the end, 30 participants were recruited, but only 40 completed the entire protocol. Testers were divided into 2 groups and run 5 times in each of the 6 mazes at a speed of first fast then slow or first slow then fast. The result is participants almost always performed better or significantly better at low speeds rather than high speeds. The learning effect was shown in 2 of the 6 mazes. The following are some useful conclusions to summarize from the experiments. It is possible to convert experience requirements into a testable set of functional requirements. But it can be difficult and can result in a large set of requirements than expected. Also, verification process of functional requirements can be difficult to implement. Develop a mathematical abstraction of the user experience for supporting design of experiment efforts is very useful, which can help developer to identify the core concept and selling point of their game. A detailed dimensional analysis of the game environment can be helpful before attempting a design experiment to give the developer an idea of the time-varying factors to be aware of. When designing the experiment, it is important to understand the dimensional complexity and apply appropriate design of experiment techniques to compensate. The user experience design goals of games are complex. Additional complexity can lead to an explosion of combination of influences and confounders, making test design and interpretation of results difficult. It is difficult to identify and assess the effect of confounding factors. This can include prior experience, learning effects, physical exhaustion, and mental boredom. When analyzing data, do your best to identify significant dimension to ensure statistical validities. Players must be able to learn fast enough to feel validated, but not so fast that they feel the game is too easy to master. Comparing results between testers is meaningless without appropriate contextual information, such as experience level and reaction time. Keeping players interested during the experiment is more challenging than expected. I suggest the following for the experiment. The number of participants should be increased. At present, 40 participants cannot deduce a general result. Make sure the game keeps the player's attention and doesn't bore the participant. Or increase the number of participants to reduce the amount of time each participant spends in the game. The cost of such verification is high, and it is needed to analyze whether it is worth it for game manufacturers to carry out such requirements verification. How to reduce the cost of verification to make it more effectively. How to develop a standardized process of requirements generation and verifications. It is clear that this article does provide guidance for requirements and testing in the game field, but it is flawed and unfinished. This topic still needs a lot of experience and data to prove. However, I think the idea put forward by this author is constructive. This process can significantly improve the success rate of the software, which I think is worth of recognition. That is my speech. Thank you.